Hello guys, welcome to my YouTube channel, and today we will be talking about RAG. So what is RAG? RAG stands for Retrieval Augmented Generation, a powerful technique in AI that enhances large language models such as your ChatGPT, Claude, Gemini by integrating external knowledge sources into their responses. Unlike traditional LLMs that rely solely on the data they were trained on during training of the models. RAG enables models to access additional up-to-date information stored in external databases or document repositories, which significantly improves their ability to answer user queries accurately and contextually. At its core, RAG operates by receiving a user's first question, which is then transformed into a mathematical vector representation using embedding techniques. This vector is matched against a vectorized database of document chunks, small manageable pieces of text. Those are chunks. That's what chunks are called. They're extracted from larger documents. The system uses similarity metrics such as cosine similarity to retrieve the most relevant chunks related to the user's query. So it retrieves the most relevant chunk, the top K chunks. You could set it to 4, 5, 6, 20 amount of chunks that you retrieve from the vector database upon each query. So the system uses cosine similarity is one of the similarity metrics which a RAG system uses to retrieve relevant chunks related to the query that was sent to the database. So these retrieved chunks are then provided as additional context plus the original query is given to the large language model, which is used to augment and generate a more informed and precise answer by combining its inherent knowledge, its training knowledge, plus the external data. So let's get into the flow chart and see how RAG works. This is an example of a RAG system. So the user sends a query, right? Sends a query to the RAG system. The query is then converted into vector embeddings by the same embedding model that was used to embed the chunks of the original document into the database. So the user's query is converted to vector embeddings, which is then used to search the database. Then you retrieve the top chunks, top K chunks, K like you can set it, the amount of chunks you want to retrieve upon each query. Then these chunks are fed plus the original user's query. They are fed into the LLM, which is used to augment and generate a response, which is then returned to the user. Now, how do these documents get into the database? This is a flowchart of the RAG ingestion process. So the document, right? We have our document. The document is split into multiple chunks. Could be chunks of 400, 1000. It's usually between 400 to 1000. You could have 250, 800. It doesn't. It's variable, right? So you split the document into multiple chunks. These chunks are then vectorized. They are converted into vector embeddings by the embedding model, and they are stored in a vector database. Now that we're done with the explanation, let's go over to the demo. All right, guys, welcome to the demo. So this is the PDF that we are going to be using for this project, for this demo project. It's a greenhouse gas protocol from the World Resources Institute. It's basically an FAQ document, that contains information about greenhouse gases, emissions, value chain emissions, businesses involvement, and oh, I don't know much about greenhouse gases, but that's why we're here. So AI will teach us from this document. All right, now let's go over to Open Web UI. The agent, the RAG agent is connected to Open Web UI via webhooks. So I think I should cover how to set that up later on in the video, but we could just test. Just gonna ask a few questions from this document. Let me ask this ask. Uh, okay, we're in Open Web UI and we are going to ask a question from this document. Let's pick this. So why? Yeah, the N8N agent is connected to Open Web UI through webhooks. I should show how to do that later on in the video. But why should businesses care about value chain automation? So it's going to send over our text to N8N workflow to the N8N agent, and we should get a response very soon. It's taking its time. Yes, businesses should care about this. Okay, give an example. Companies like Kraft Foods. So let's come to the document, search Kraft. Okay, we have Kraft Foods. Okay, good. We have Kraft Foods found that value chain emissions comprise more than 90% of the company's total emissions. And we got that same text in Open Web UI. We got Kraft Foods found a value chain. So let's go over to the N8N workflow and see how the chunks were pulled and everything. Okay, we're in N8N. We could just check the logs. Yeah, we get our inputs. Why should businesses care about value chain emissions? The query was then embedded by the embedding model nomic embed text, and we pulled it pulled these chunks. It pulled the top 4 chunks relating to that query. Chunks are just basic part of the document as I explained in the intro. Yes. So we can see the chunks we pulled. Then you can see the input to the LLM, which is some of the system prompts, chunks it pulled, and the user's query, which is then used to generate our response. Okay, enough about the demo. Let's get to building. Yeah, we're back here in N8N and we are about to build the project from scratch. So the first thing in any RAG pipeline is the ingestion. So we have to get the documents, break it into chunks, and embed it into a vector database. So that's what we're going to do right now. Trigger manually, then get our file from disk. You can also use Google Drive, OneDrive, whatever cloud platform where the document is hosted can be done. Yeah, before that, we actually have to get the document into the server. So we get this just to download the PDF into we just call it document.pdf. Good. Yeah, our document is in the server. Next thing we're going to do is connect to it. Wait a minute. Yeah, okay. Select the share. Okay, so data the shared documents.pdf. You could connect your Google Drive, cloud, wherever your file is, you can always just connect it and get your files. Okay, yeah, the PDF is pulled. So we're going to use next node extract extract from PDF. Okay, so this node extracted information about our PDF. We can see the PDF version. You can see the creator, producer, number of pages, metadata about the PDF, and then finally the text. Okay, so the next thing we're going to do is create a collection in our vector database. A collection is basically it's basically a table where we can store our vectors that we extract from our PDF, that we embed from our PDF. So go to Qdrant, create a collection. We can just name it call 3 use case because it's a simple project, global search, simple single embedded. Now for this dimension of the vector configuration, depending on the embedding model you are using, you could just make a quick search. You can just make a quick search of your embedding model's vector dimension and get the value of that. Okay, so 768 because I'm using nomic embed text. My vector dimensions will be 768 and we'll just leave the metric as cosine. Leave payload, leave that one, then finish. Call 3. Now we add our Qdrant node. We want to add documents to our vector store. From this, call 3, the one we just created. Embedding batch size is basically the number of documents you want to embed in a single batch. Since it's just one document, we can leave it as 1. You can also leave it as 200. It doesn't really matter, at least not right now. Yes, now connect our embedding model. You could use whatever embedding model you have. There are some embedding models from OpenRouter. You could use you could use embeddings from OpenAI, Text3 small, Text3 large, whatever embedding model you have, you can just connect it. But I will be using nomic embedded text. Let's call this one nomic embedded text. Now the document loader, we use a default data loader, and then you could use a simple text splitting or a custom text splitting. But for this example, we are going to be using a custom because there's no need for overlap since we are using a relatively small document. So chunk size 1000 and chunk overlap. We're basically just taking every 1000 words and splitting. We take every 1000 words from the document and split them into chunks, then embed them in the database. Yeah, so we need to set a few things from here. We need to load specific data. Yes, this data field is where we are going to input the text from the PDF, text extracted from the PDF that we want to chunk. This is what we're going to drag into this place. We already have a custom text written. We are not adding any metadata since it's a very simple rag. So all left is to run, to hit run. Okay, so we can see we have 9 items that was output here. Means the PDF was split into 9 different chunks. Yeah, we can see it was split into 9 different chunks. All right, so yeah, let's check the text splitter. Oh, we used the character text splitter. Oh, that was a mistake. It should not have been. It should have been a recursive one. Okay. Yeah, sorry about that, guys. Let me go fix that and I'll be back. Yeah, and we're back. Right. So the major difference, the major reason why I had to switch out the thing and change it back to recursive character text splitter is characters are split differently by those two nodes. So the first one, the regular character text splitter, just split text after every uh, 1000 words. But the recursive character text splitter uses context aware chunking, where it splits based on multiple hierarchies such as headers, paragraphs, words, and then characters. Anyway, it's the best one, really, yeah, for this project. Anyways, we have 11 chunks in our database. We can see each chunk with a little metadata that contains the lines from line 1 to line 13. This one contains line 24 to line 32. It's a chunk. Let's scroll up. It's chunk 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So those are our chunks. This is the splitting recursively by the recursive character text splitter. Anyways, that's part 1 of the project done. So we have our, well, this is not RAG pipeline. We have our uh, ingestion done. So let's call this, put it here. Okay, now the next part is the retrieval process, the retrieval rag agent. So we're going to be building that out now. So what do we need? We need a chat trigger that are connected to an agent. Yeah, chat trigger node. We have a system prompt. Connect our chat model. I'm going to be using Mistral 3.2 because it's a really tiny project. You could use OpenAI, Anthropic, Gemini, whatever uh, language models API key you have, you can use it. So I just prefer naming them that way. It's cooler. And for the memory, we're going to be using Postgres because why not? Internal. Yes, yes. You could also use a simple memory for the agent. Doesn't really, it matters, but for this, it doesn't really matter. Now the tool will be our vector store, Qdrant vector store. Yes, connect to our collection, the collection 3 that we created. We can limit this field, limits the number of chunks top results to fetch from the vector store. So we can leave it as 4 or 5, or I think 5 is pretty cool. Include metadata. Yes, retrieve to so we can just add a description. Retrieve document. So store. Yep. and then we connect the same embedding model which we use to embed the chunks into the database. This is very important. It has to be the same embedding model. If not, you'll be getting wrong and weird responses because each embedding model processes vectors differently. So connect that, then the system prompts. Nothing fancy about the system prompts, just personal system, create vector database for information, and we're all set. So open chat. New session, new session. Yeah, so we could just say hi. Okay. What is GHG? Good. So we got our response. GHG stands for greenhouse gases. We can see that the agent made a tool call to our vector database. We got this input. What is GHG? Sends that input to the embedding model. The embedding model converted that query into vectors and it pulled these chunks from the vector database. So we can see the chunks it pulled, the top 5 chunks it pulled, 1, 2, 3, 4, the 5 chunks it pulled that have the term GHG, they are semantically similar to the query that was asked and we got this response. So we can ask it again. What was the question we asked it earlier? Name info. Let's ask it another question. Why should businesses care about value chain? You can see it querying our database, pulling chunks. Yes. Aha. This response is very similar to the one we got when we queried it earlier. Significant emissions impact, positive return on investment, stakeholder engagement, and reputation. And these are the similar things we got. We got craft foods, the craft foods mentioned. We could search again, craft foods, and yeah, so that's the project, simple rag. Now, because this is extremely simple and not so technical implementation of rag, there are bound to be hallucinations and incorrect responses. RAG itself is not completely perfect, which is why there's always new development, new methods. We have stuff like Agentic RAG, Graph RAG, different types of RAG uh, technologies and advancements have been happening over the last few months. So this is pretty good for a start. I'm going to make videos on more complex and more technical versions and types of RAG to enable us to get grounded and factual, consistent answers from our documents. Uh, like, subscribe, stay tuned. Uh, see you on the